at today is, go back over to this. We're going to start talking some digital circuits, and I've got a bunch of these buckets with kits. I'll explain all that in just a moment. But essentially what we want to do is start to actually build stuff with a transistor and then multiple transistors. And then if you imagine sort of several thousand of them, then you could get a very simple microprocessor. Okay, so we'll start with the parts in the kit here that we've got. And so we're going to be using an Arduino, which is a simple little microcontroller, pretty low power. They're very inexpensive. And essentially, we're just going to use it for two reasons. One, as just sort of a nice regulated power source. And two, there are a bunch of these little pins here that we can, using software, tell whether or not to turn them on or off. And that will be convenient for a number of reasons. So, okay, so just this first circuit here is nothing particularly exciting. So what are all the components here? We have an LED, a resistor, this big grid is called a breadboard, and then some wires. Now, the way that these breadboards are designed is, you see this very top row, you probably can't see it on the screen, but it's, well, maybe you can. That's sort of green. Okay, those are all connected to each other internally. And the row right under it is all connected to itself internally, and same with the two rows on the bottom. Then in the middle, the things are connected in columns. So this, right there, it says 30. These 5 pins are internally connected. And then across the break, these 5 pins are internally connected. Okay, so basically what you use the top and the bottom one for is for power and ground, and then you plug all your components into the ones in the middle, knowing two things: that each column is internally connected and they're not connected across the little divider. So if you need to connect across the divider, you got to put a wire there. Okay, so the circuit here. So first off, the convention here on, I mean, how many of you guys have ever like changed a socket in your house or something like that? Okay, so red wire is generally the hot, okay, and then black is black, or in a lot of times in houses it's green instead, ground, okay, and then in household electronics, you also usually see a white cable, okay, and that's because it's AC, not DC. But for DC, the convention is black for positive, black for I need coffee. Black is negative or ground, and red is positive. Okay, it's the same way in your car. Has anybody had to jump start a car recently? Yeah, huh? You remember the order to clip everything on? Yeah. So okay. So the convention, and this is somewhat irritating, is which direction does charge flow or current flow? Yeah, conventionally positive to negative, but guess what? That's the exact opposite of what actually happens. They go the other way, right? So conventional current, and we've been using this so long that we'll just stick with it, okay? Like longer than the electron was just, like conventional current has been used before the electron was even discovered, okay? So current conventionally flows from positive to ground or negative, even though the actual electrons do the exact opposite. I'm pretty sure it was Ben Franklin we can blame for that. He had a 50-50 chance and he blew it, okay, in terms of which direction to call positive and negative. Okay, c'est la vie. That's just the direction we got, and so we have to stick with it. Okay, yes. I don't know. What do you think? It might be a good idea. All right, now that said, hang on one second, Thomas. These notes here are hot linked off of Canvas, and they point to this in my Dropbox account. So as I update these are very much a work in progress. The link will always point you to the most recent version. And I tried to remember to update the date. I didn't on Friday, and that's my bad. Okay, so so we've got our positive, we've got our ground. Thomas, you had a question, sorry. Mm-hmm. Yeah, you get your hands on some antimatter, and well, then we can talk. Build a warp drive first. So, all right. So the LED, you guys see that it has that little crook on the edge of it, like okay, that corresponds to in the real thing. Where do I have them? Yes. Okay, because so an LED, there's one long side and one short side, and they're not. It's not hugely noticeable. Okay, but an LED is a diode. So a diode is a component that only allows current to flow one direction through it. So it's like a one-way valve or something. And an LED is just one of these that also gives off light, hence the name. Okay, so the it won't function correctly, or you won't see anything if it's plugged in backwards. Okay, there are plenty of components that don't matter which way you plug them in, but an LED does. Okay, so on the diagram here, we have the positive end is the one that's got the crook. That's the long one on the actual part. And then the other one, the short end, is your negative. Okay, so this is a little loopy, but I go from plus 5 volts on the board over to the power rail. From the power rail to here, and then there's this little part, okay? And this little part is called a resistor. So um, you can think of electricity as kind of being like water flowing through a garden hose. If you put a kink in it, then it's going to limit the amount of water that can flow through it. And if there's no kink, then it'll just start gushing out. Okay. If we do not put a resistor, we'll put too much power through the LED and it'll burn out. Okay. So the purpose of the resistor is to limit the amount of current that's going through and not set things on fire. Generally a good thing when working with electronics. Okay, now the resistance of that resistor, you need to basically select it knowing the characteristics of whatever you want to use. And for this, we'll use a 330 ohm resistor, not really all that big, but enough to keep it from burning out. And then it's wired to ground. Okay, so nothing particularly exciting. But now let's actually wire this up and make sure it works correctly. So for that, let me go back to the webcam. Okay. All right, so let me kind of clean up some of this stuff that I was doing the other day. All right, so I've got here my power and my ground. Okay, and is this sufficiently viewable? Yeah, okay. And then I've got the resistor going from the power to the long side, And then all I need to do is put a wire going from the here to ground, okay, and then plug it in, okay, and voila, the light's on, okay. Although in the camera, it may not it doesn't really look like it's on. There it is, just from the angle. Okay, so not rocket science, hopefully. Yeah, but getting there. Okay, so that's not particularly exciting. Okay, that we just have a light that's on. Yay. Okay. All right. So the next for my next trick, we're going to talk about the transistor. Okay, which hopefully you guys learned a fair bit about in the videos. What you guys think of the documentaries, by the way? Learn a lot? Hopefully. Hopefully there was like, wow, there was a whole lot of stuff that wasn't just technical in this. Like, who knew that like communism was a central part of the story, right? Um, okay, so all right, so I'll make a minor modification to this circuit in a moment, but let's start talking about a transistor. Okay, so a transistor, let's see, where is the, here we go. They're pretty tiny, okay, this thing, right? This replaces an entire vacuum tube, so you can see why things got miniaturized to the extent that they do. All right, so there are lots of different kinds of transistors, and we're going to look at sort of two major categories, and then within those two categories, there's kind of a couple of subcategories, okay? And the two major categories that we'll look at are bipolar junction transistors, or BJTs for short, okay? And then the second major category we'll look at are metal oxide semiconductor field effect transistors. Say that 5 times fast, okay? Or MOSFETs for short, okay? All right, so the bipolar junction ones are much older. They were basically like the second kind that really was commercially viable. And they're inexpensive, they're pretty reliable, and the way that they're produced is using a semiconductor material. Okay, so silicon is pretty commonly used. There's others like germanium and stuff, but silicon has a distinct advantage, namely, where do you find it? Yeah, all over the place. There is just tons of silicon laying around all over beaches and stuff, right? So there's no shortage of it. Um, okay, so inside this silicon, different parts of it are what is called doped. And doping uh, is a process where you deliberately introduce impurities in the silicon. Okay, so you either put little bits of boron in it, or phosphorus, or other materials, and by doping it, you change its electrical properties. And by putting several doped layers together in the right way, then this you get this effect, this transistor effect, and that is useful. Okay, as we'll see. Okay, so the diagram for a transistor, or for, okay, so let me back up for a second. BJTs, that's the category we're going to look at first. There are two subcategories within that, NPN, and then the other one is called PNP. And the N and the P's basically refer to the doping pattern within the material. Okay, here's the diagram for it in terms of like a circuit layout. And so there are 3 pins on it, and they're called the base, the collector, and the emitter. Okay, well, looks like we all got an email. Oh, professional development, new staff. Okay, so the base collector and the emitter. All right, now if I put this on the webcam, so let me switch back over to that real quick. Okay, it's how do I know which leg is which? Okay, well, one thing I can see is you see how the body of the thing has sort of a flat face and then the other face is kind of rounded. Look with the flat face or the flat surface facing towards you, okay? And when you have that in that orientation, the base is in the middle, the collector is on the left, and the emitter is on the right, okay? So that's how we know which one is which, and we've got to have it in the correct order for this to work correctly. Okay, so what is the function of the transistor? So if I put a current or I connect something, a power source to the base, okay, then a very small amount of current will flow from the base out the emitter, okay? When that happens, it induces a larger current that flows from the collector out the emitter, okay? So the original application of this, so there's two uses for it. One is as a switch, and the other is as an amplifier, okay? So let's say that you've got a radio signal that's really weak, but you need to amplify it so that you can hear it, okay? Well, what you would do is put the signal connected to the base, and then you'd connect your speaker out the emitter. So this very weak signal coming in from the radio would be amplified so that you'd be able to hear it. Okay, does that make sense? Yeah, okay. And so the original commercial application of this were in portable radios, okay? I think I mentioned back in the day how, you'd have to take your, like if you had a household radio that had a vacuum tube in it and the tubes would eventually burn out, right? You'd have to take the tube out and go to the drugstore or the hardware store, and there'd be just shelves full of different tubes of different types. And they'd even have testers, and you could plug it in and see, yes, in fact, it's bad, and then get the appropriate replacement part. Really, it was just like buying a light bulb. Although, when's the last time any of you guys bought a light bulb nowadays? Yeah, because they last 20 years. Okay, so that was the first commercial application, but this can also be used as a switch, right? So if I want to turn on current flowing from the collector to the emitter, all I have to do is put a little bit of current on the base, okay? And so it's a switch that's controlled by a little bit of electric current. Does that kind of make sense? I mean, the idea anyway. Now, in terms of how this works on a physics level, for our purposes, we might as well just treat this as magic for right this instant. And you can become a physics major if you really wanted to learn it. Okay, so let me take my transistor here and let's get this into our circuit. Okay, so I'm going to pull everything out here for now. Okay, so I'm going to put back in, oh, I'm sorry. Yeah. You mean you guys aren't psychic? No? Okay, so make sure I've got the right one here. Nope, that is not the, well, I'll just use this one. That's fine for right now. So I'm actually have a MOSFET in my fingers, and I wanted to have a BJT. Okay, so what I'm going to do is I'm going to connect positive to the collector, a resistor off the emitter, and then my LED, and I'll go to ground. Okay, so you'll notice it's not on, right? Okay, why isn't it on? What's missing? Yeah. Yeah, there's nothing connected to the base at the moment. Okay. So, when I said that you put a current through the base, you put a very, very small current through the base. So I have a resistor that I'm going to put to limit the amount of current going into the base. And this particular resistor is 10 kilo ohms. Okay, so that's a really high resistance. I'm putting just a tiniest dab of current into the base. Okay, so let me connect that. And then I'll just use straight positive for this. It's okay, right? And the LED turns on only when I apply this small current to the base. Okay, and you guys can't see the LED. I'm sorry. Okay, so does that kind of make sense? All right, so let me go back to the notes for a second. Okay, so we're going to start to make basically slightly more complicated circuits. And what we're going to do is, you saw how right there I was just manually connecting the circuit with the wire. Instead, we'll take advantage of the fact that we can program the Arduino to turn on and off some of these pins that are at the side. Okay, so you see here these pins that are up there that are numbered. Using a very small program, I can tell the Arduino to turn those things on or off, and then the breadboard just sits there, and I'm not connecting things myself. Okay, so the code that I'm going to use for that, if you click on this in the notes, it will actually take you to Dropbox and download it. Okay, and then if I go to the Arduino software, this is the thing I asked you guys to download, by the way. Okay, so all this program is going to do, oh, and you guys can't see it, I'm sorry. Okay, there's two sections here to the code. The first just sets up basically configuring, do I want the pins set up as inputs or outputs? And in this case, I'm only going to use pin number 2, along with the 5 volts and the ground. Okay, so I'm going to initialize pin 2 as an output, and then I'm going to loop, and so this loop will run basically forever. I'm going to turn pin 2 high, wait a second, turn pin 2 low, wait another second. Okay, so this will just make the thing pin 2 cycle on and off at a 1 second frequency. Nothing particularly exciting. Okay, all right, now once I've written this, I have to upload the code to the board, and when you plug it in, it should auto detect, and then it goes there. All right, so what I'm going to do now is I'm going to change my circuit, and I'm going to connect this wire to pin 2, okay, and then get the camera back on. Okay, and you see the LED is now blinking once per second. Okay, cool? Yeah. All right, so now basically let's get our hands dirty and start to wire this stuff up. Okay, so we've got the buckets, so get in groups of 3, and all right, so open up the buckets, and let's talk about all the different things that are inside. All right, so like I said, group up into triads, please. No, plus 3. I need to get some more of these. Okay, so first off, look at what is inside your bucket. Okay, let's talk about the different things inside. All right, so you have an Arduino Uno that's in one of the boxes. You can go ahead and open that up. Okay. Well, not all of them are brand new. Yeah, because there's 8 buckets. So there's 8 buckets and 24U, and 24 divided by 8 is 3. Last time I checked. So, okay. So inside you've got your Arduino. Okay, you've got a big bucket of wires, or big bag of wires. You've got 3 breadboards. You also have a multimeter. Well, we don't need the multimeter right this instant, but we'll use it eventually. Okay, so the multimeter will allow us to measure voltage and current and all of that stuff, and that'll become useful later. Okay, but in particular, you notice that you're probably missing some stuff. Okay, and so for that, you all need one of these. Okay, so here are your transistors. Okay, and I've labeled these here BJTN because these are BJTs and they're NPNs. And as we go through things, we'll keep adding components to your buckets. Okay, now the other things that you need are you need some LEDs. Okay, so grab like 4 or 5 of those and then pass the thing down. You're also going to need some resistors, and so I'm going to give you the baggies for that, and then I'll actually give you the parts. Huh? I know. Yeah. They are empty at the moment, but I've got the box with the parts to go around. All right, so let's see. We need 1K, 1K, 330s. Okay. Where's my knife? Okay, so the resistors, you need basically about 10 of them. Okay, so they're on these little like cardboard pieces, so just count 10 and then tear, this is just like paper, so just count 10 of them, tear them off, and then put them in the 330 so you don't get them mixed up. And then the other ones we need are the 10Ks. Okay, so the LEDs are coming around, resistors are coming around, and yeah, so you get the resistors that are coming around. You're going to get 10 of each of the resistances, 330s first, and then I'll get the 10Ks coming. Okay, and then we need the 10Ks. 10K, here we go. All right, 10Ks. 10K resistors, so take 10 of those too. No. Different resistance, same type of thing though. Okay, so what I'd like you guys to do is start to wire together circuit number, start with circuit number 2, okay, which is this one here. So we've got on that 2 LEDs, okay, and pick 2 different colors, so that doesn't really make a difference. For each LED, we need a 330 ohm resistor, because otherwise we'll burn it out, okay? And we're basically going to have the red LED in the picture, though your color, it doesn't matter which colors you use, will be always on because it's just connected straight to power. And the other one is connected to pin 2 using that program that I did, okay? All right, so we good? Yeah, to start wiring it up? Okay, and then we'll add the transistor to this to get it basically how I have it in my circuit. Okay, so the 10Ks should be going around. Grab 10 of those. And so you won't need the 10Ks for this circuit just yet, but you will in a minute, okay? Okay, so does this kind of make sense? Yeah. All right, so now the other thing you'll maybe notice is you see the bottom rail. Where am I putting pin 2? I'm connecting it to one of the rails. That's mostly for convenience. Okay, you don't have to, but it's there, so you might as well take advantage of it. Okay. Okay. Hmm?
Does it matter which one I plug it into?
If there's multiple now, they're just there for convenience. Yeah, so you guys may have noticed these. Did you already get the 10Ks? Yeah. Yeah, 10K. Uh,
Orange, black.
yes. Good. Thank you for bringing that up because. Okay. So, how do you tell which resistors are which, by the way? You see those little colored bands on them? Yeah, there's a pattern for that, okay? And then you look at the handy dandy cheat sheet. Okay, now, this is one reason I put labels on the bags, just to keep this from being irritating. Okay, but, and I need to make more copies of the cheat sheet because I don't have enough. You look at the bands, and that tells you you can read off the resistance. Okay, it's kind of an annoying system, and you just have to get used to it because there's kind of some weird idiosyncrasies. The other way to do it, which if you're colorblind is really the only option you have, is to use the multimeter. Okay, so you can put the multimeter in resistance mode, just connect it across both sides of the resistor and read it off, and then you know what it is. Okay. Yeah, so if anybody's colorblind, then that's really the only option you've got. Okay. Okay, so in terms of the code, if you click on the sorry, what is it? The link in the here, this guy. If you click on that, it will actually download the program for you. Okay, or you can just copy and paste out of that and put it into the Arduino thing. Okay. All right, let me go back to the picture so that you guys can see it.
We use a 330 or a 10K.
330s for these. Yeah. If you use a 10K with the LEDs, you won't see them. Right? It's just it'll be way too much resistance. Okay. Did everybody get the 330s and the 10Ks resistors? Okay. Are those 330s? Okay.
Those are from that.
Okay. So you've got your 330s. Where are the 10Ks? Who's got the other stack of resistors? Who has the marijuana? I'm going to need the marijuana back, please. No. Okay, seriously, where did the 10Ks go? Yeah. Who has the 10Ks? I know I gave them to you guys. You gave them there. You gave them there. Did you get 10Ks? Okay. Do you guys have the 10Ks? Ah, here they are. Okay. Did you get your 10? Did you take 10 off of this? Take 10 of these, yeah, and put in here. And then did you take 10 of these, the 330s? You've got some of them. You've got 5. Where's the other? Here, take 5 more of these. Okay. All right. Did you guys get 10Ks? No. Okay. Okay. Once you've got it wired up, go ahead and plug it in and make sure it works, and hopefully you don't set anything on fire. That'd be great. Okay. And then where's the ones you tore off of? Ah. Okay. Did you get your 10Ks? Okay. No, you're fine. Okay. Thank you. Okay, so looks like you guys mostly have them close to wired up. Go ahead and plug it in and make sure it works correctly. Hopefully, will work faster. Okay, looks good. Makes sense. Okay, looks good. Yeah, just into a USB port. Yeah, that's all. Okay, so hopefully this isn't rocket science. Does it kind of make sense? Huh? Got it? Excellent. All right, so then what we want to, after you've got this one working, we're going to add in the transistor, which is circuit number 3, or 4, excuse me. What now? Oh, it should be inside the box with the Arduino. No. Was there not a USB cable? No, there. You mean this one right here?
You pull everything out of the box.
No, you didn't pull everything out of the box.
I didn't even touch the box.
If it's a snake, you'd be dead, as my father would say.
Which one was off? Why is that turned off? Oh wait, hold on. Is it
Okay. So what's happening is the Arduino stores the last program uploaded to it. So when you plug it in, it starts running it immediately. And whatever code is on there now is doing a different pattern than the 1 second, 1 second. Okay. So you just have to plug it in, open the program, and re-upload the code to the board. So hit the little play button. No, the one to its right. That one.
Which one did you replace to make it light up? Which one were we off? Which wire?
We just had to move the LED one over.
Oh, gotcha.
Yep.
Did you do it?
Let me try it again.
Oh, error.
Serial port not detected.
Okay.
Is this plugged into the right?
It is, but here, go back to the program, and then what we need to do is say board port COM3, and you'll see the lights. Yeah.
So now.
That's weird.
Maybe I need to upload it again now that we've changed the port.
No.
We might have a bad LED.
It's possible. Here, swap that out for a different one.
Long end on the resistor, right?
Yeah, because long end is positive.
Yeah.
Okay.
But it's still on. It should be blinking. Oh, it's because you plugged into pin 1, not pin 2.
Okay.
Yeah.
That one's perfect.
Because there is a pin 0.
So what's it? Can I ask that a question? So why is pin 1? I guess this may be a straightforward. Why is pin 2 so much different than pin 1?
So pin 0 and 1 are reserved for certain functions, for like data transmission. And I mean, we could use pin 1, but because it's really designed to be something else.
Gotcha.
There's no other difference though. Like there's nothing different about pin 2 versus pin 4, right? It's just, they're all the same thing. Okay. Yeah. All right. So let's see. Okay. So 2 things. You see how you have this vertically?
Yeah.
Those are all connected. So this is actually short circuited.
Oh.
Okay. So and we're missing the resistors. Okay. We need 330 resistors or else we're going to burn this out. Okay. So what we'll do is we'll put the short end there on ground, but right now the green LED is not actually, there's no full circuit, right? It goes from the short one down to ground, but there's nothing coming in power. Okay, so for that, give me a 330 resistor. These. Yeah, okay. So this needs to connect here and here. Okay. So remember, on a column, these 5 are all connected internally. So if you plug something into one and something into the other, they are touching inside. So, but from this one and this one are not connected. So you had it basically turn 90 degrees, and then this one has the same problem. Okay, so put that there. You need another resistor for the blue one. Okay, does that make sense? Yeah. Okay. All right, so are we starting to get there? Yep, looks good. All right, is this making sense? Okay. So, we got just a couple quick minutes before we finish today. Okay, so where we're going to go with this, and this is the thing we'll start with right at the very beginning, is what happens if I put 2 transistors in? Okay, yeah. In this case, yeah. So if one transistor can be controlled by a single input, if I had 2 transistors and I controlled one with one input and the other with the other input, then if I put them in a line, then I can make it so that the output is only on if both inputs are on. Exactly. Okay, so how many of you guys in high school did like digital, like AND gates, OR gates, NANDs, NORA, that sort of stuff? That's what we can build with these, right? 2 transistors is enough to build an AND gate, an OR gate, a single transistor. Actually, you could build a NOT gate if you wanted. Okay, so that's where we're going to go with this on Wednesday. But for now, is this kind of making sense?
Yeah.
Yeah. Okay. 1 second, Thomas. So the later today, okay, these buckets are all going to end up over in the library, and they're going to be you can get them from the reserve desk. So we'll do some stuff in class, and you guys are going to do some stuff out of class. Okay. We'll talk about that Wednesday. We're not quite there yet. Yeah. Okay. But does this make sense?
Yep.
Okay. Question. I'll show you in a minute. Okay. You'd have to use a pull resistor, but yeah. Okay. So if you could be so kind as to put everything back neatly into your bucket, okay, and you can disconnect the circuit if you want, or leave it connected, whatever. Okay. The other thing, if you could grab a piece of paper, just a blank piece of paper, and write down your names as to who's working with you in your bucket, okay, and just put that inside the bucket, and then also maybe just exchange Snapchats or whatever you guys do. Oh, just put them in the bucket. I've got some bags that you can put those in. I forgot to bring them. So, okay. All right. So does that make sense? No? All right. Well, we'll quit the stream then.